This is a operational description of a Pulsa carburetor. We'll start over here on the intake stroke. You can see that'll be on this side. On the intake stroke, the piston moves down in the cylinder, and when the piston moves down in the cylinder, it creates a vacuum, drawing air through the carburetor just like that. As air rushes past the fuel pump body, which is right behind this diaphragm, it draws the diaphragm down towards the fuel pump body, down in towards the fuel pump body. When that little rubber diaphragm is sucked down in, a vacuum is created on the outside of the diaphragm. When a vacuum is created on the outside of the diaphragm, it pulls this little flap open up towards us in the picture. And when it does that, a low pressure area is here. We have a high pressure area here, which is atmospheric pressure. Because there's a pressure differential, fuel moves up through the valve into that little pocket, which is on the other side of this little pocket of the cover. So now we have fuel in there. The intake stroke is done, and we start to come up on the compression stroke, and the intake valve closes. When that happens, air doesn't rush past as fast, and when air doesn't rush past as fast, the little spring behind the diaphragm pushes out. When it pushes out, it pushes on that diaphragm, and the little bit of fuel that was in there gets pushed out. This valve opens and gets pushed down, and it goes down into the fuel cup, which sits right there. I'll draw that fuel cup a little more permanently so that it'll stay there. So now it's down inside that fuel cup, and every time there's an intake stroke, whenever the piston goes down in the cylinder on an intake stroke, this diaphragm is moving in, and then the intake stroke is done, and it moves out, so it's flapping back and forth and sucking fuel in from the bottom of the tank and then pushing it down into the tank. So that's really the first step of the Pulsa carburetor, to suck fuel from the bottom of the tank and put it into the fuel cup. The next step also happens on an intake stroke, and when an intake stroke happens, the intake valve opens and air is drawn into the carburetor, around the carburetor elbow. Now I'm going to draw the venturi right here. The venturi sits like that, and then the tube on the venturi goes down to the bottom of the fuel cup tube. So let me draw that venturi again, and then the tube goes all the way down there. Now air rushes in through past the carburetor elbow, past the jet. We're going to call that a jet. This little hole right here is a jet. And when it goes past the venturi, an increase in velocity equals a decrease in pressure. And that is Bernoulli's principle. So an increase in velocity equals a decrease in pressure. And when that happens, you have a low pressure area at the jet. We have a high pressure area down here, which is atmospheric pressure, which causes the fuel to move up the fuel cup tube into the path of the air. Remember, the air is rushing past here and goes over the bump. There's some turbulence created, and that causes the fuel to atomize, and it gets delivered to the cylinder when the piston is going down on the intake stroke.